Alright, so now we're going to talk about absolute magnitude, which is when we're starting to look at not our apparent magnitude, which is brightness, but we're actually going to be looking at the luminosity, or attempting to find the luminosity of the star. And in this case, we are looking at pushing or pulling a star to the same distance from everything. We are going to be pulling and pushing from 10 parsecs. 10 parsecs, okay? We need our star to be there, which means we're going to have two equations that we can choose from. We can either use 10 over the amount of x parsecs where the star is right now, or we can use the amount of parsecs the star is at now over 10. Either way, it's going to be the one that doesn't give us a decimal, okay? So if you are pushing the star away, okay, pushing it away because it's too close, you will be using number 1. If you are pulling the star towards you because it is far, far away, like it is 4,000 parsecs away, it needs to come closer if it's going to become 10, you are going to use number 2, okay? And so in this case, this one means we're pushing away, so it needs to go farther, and this one means we're pulling, so it needs to come closer. If we're using number 1, your star will get dimmer. If we're using number 2, your star will get brighter. So in this case, we will subtract because we need the smaller number, and in this case, we are going to add because it should become a bigger number, okay? So let's start with our first one. Star 1, star A, sorry, that's a little big, has an absolute magnitude. So remember, absolute magnitude is defined by big M, not the little m. Little m is apparent magnitude. So star A has an absolute magnitude of something, okay, so that's what we need to find. What we know is its apparent magnitude is plus 2. We also know that it is 40 parsecs away. Okay, so we're going to be thinking about this. It's 40 parsecs away. Which equation are we going to use? 1 or 2? Oh, we're going to use 2 because we need to bring it closer to us because it is farther away. So we will do 40 over 10. Our parsecs are going to cancel out, so they don't matter. And we are going to get 4. Okay? And then what we're going to do with this is square it, which will give us 16. So we know that the difference in brightness is going to be 16 times. Okay? It's moving 16 times closer, meaning its brightness is going to change by 16 times. So if we take 16 times, okay, 16 becomes 2.5 to the third, and we know that that 3 is going to be the difference in magnitude. Okay, and since it's coming closer, it's going to get brighter, which means we need to make it smaller, so we're going to do plus 2 minus 3, which means our absolute magnitude is going to be minus 1. Okay? Hopefully that makes a little bit of sense to you guys. And so let's try again. In this case, we're going to have star B. It's going to have an apparent magnitude of plus 3, and this time it's going to be 100 parsecs away. Okay? And again, we need to find absolute magnitude. Alright, so what we have here is 100 parsecs. We know we are still going to use option 2, equation 2, because we still need to bring it closer, okay? Which means it still needs to become bright, which means we're going to have to subtract. So let's start with 100 parsecs. Again, because we're doing 100 parsecs over 10 parsecs, they do cancel out, so I'm just not going to write them in. So in this case, we're going to end up with 10, and we're going to square it, which is going to give us 100 times closer. Okay? And 100 is easy to break down. We see it on here in our definition side. It's going to be 2.5 to the 5th, which is pretty simple, which means we are going to have 5 times a difference in magnitude. Right? And since we're subtracting, we're going to do plus 3 minus 5, and that's going to equal minus 2. Okay, so our absolute magnitude in this case is going to be minus 2. Okay? Alright, let's give one more go for this one. Alright, let's do another one, again, coming closer. Okay, so star C. It's going to have an apparent magnitude of, let's say, -2. Right? And it is 20 parsecs away. Okay? Even though it is just slightly over 10, we still need to bring it closer, so we're still going to use equation number 2. We need to find, again, absolute magnitude. Okay? So we're going to do 20 over 10. Okay? Which will give us 2. And if we square that, we get 4. So you know what? I can't do this easily with you guys, so we're going to pick a different one. It's not going to be 20. I apologize. We're actually going to use 30 squared times 5 squared, 25. 40, 50. Let's see. What's one I can use here? Alright, we're going to use 4,000 parsecs. Okay, I know that's huge, but it's 4,000 parsecs away. Mostly because I'm trying to pick something that I can easily do on here with you guys that won't end up being confusing later, especially when it really lines up easily with what's on our chart. Okay, so again, we're still using number 2, so 4,000 divided by 10, because we've already gotten rid of parsecs, leaves us with 400. Okay, and we're squaring it. Okay, so when you do 400 squared, you get 160,000. Okay, means we have moved a difference of 160,000 times difference in brightness. Okay, we've moved 400 times closer, and we have 160,000 times difference in brightness. Okay, so now we need to break this down. 160,000 is broken down into 3 bits. 100 times 100 times 16, which we did previously. That's why I picked this one. So we're going to end up with 2.5 to the 5th times 2.5 to the 5th times 2.5 to the 3rd. Okay, and that's going to give us 5 plus 5 plus 3, 13 times difference. Okay, and remember, we're subtracting because we're pulling it closer. So -2 minus 13 is going to give us a total of -15 as our luminosity. That's a pretty luminous star. Okay, and that's how we figure this out. Okay, so remember that you're moving so many times closer when you do this division, and then we have to square it so we can get our difference in brightness. Okay, which we then have to turn into exponential form, and then we'll figure out the difference in magnitude from that. And that's how you find absolute magnitude for coming closer. So now let's try and give it a go for going farther away. Okay, so now we're going to try going farther. So we're going to be using perpetually option 1, because we have to push it away, which means it's going to become dimmer, so we're going to have to add. Alright, so star A has an apparent magnitude of -2. It seems very bright, but it is 2.5 parsecs away. Okay, so this is rather close to us, so we're going to have to push it away, and we want to find our absolute magnitude. So here we have to do 10 over 2.5. Okay, so 10 over 2.5 is going to give us 4 times closer. Okay, but again, we have to square it so that we can get that difference in brightness. So we know we have a 16 times difference in brightness. Okay, and 16 breaks down into 2.5 to the 3rd power, which means our difference in magnitude is now 3. Okay, you seeing how we're doing this? And since we are getting closer, and so the star is getting dimmer, we have to add. So -2 plus 3 is going to give us a +1. So our absolute magnitude is +1. Okay, so the star is much less luminous than it appears to be. Let's give another go. Same thing. We're going to try closer. Okay. Star B has an apparent magnitude of, let's say, +3. It is 4 parsecs away. Okay. Again, away using option 1, we need to push it farther, so we have to do 10 over 4. Again, because both have parsecs, so we're just going to delete those out. And 10 over 4 is going to give us 2.5. So we have moved 2.5 times farther away. Okay, and don't forget we have to square it in order to get our difference in brightness. So our difference in brightness is going to be a total of 6.25. Okay, that is our difference in brightness. So now let's turn that into an exponential form. 2.5, or 6.25 is going to be 2.5 to the second power. Okay. And so now we're going to keep going with that. 2.5 to the second power, which means our difference in magnitude is 2. And since we moved away, that means we have to add, because the star has to get dimmer, so we do plus 3 plus 2, which means our absolute magnitude is plus 5. Alright, so that means your absolute magnitude is going to be plus 5. Okay. Alright. So we're going to do, I'm going to work on this with you guys. We're going to do 2 more. It's going to be one's farther and one's closer. So let's start with star D. Star D has an apparent magnitude of plus 4, and it is 2.5 parsecs away. Okay, so 2.5, gotta use option 1, 10 over 2.5. Okay, again, crossing out the parsecs, and 10 over 2.5 gives us 4. So that means we're going 4 times closer again, and we need to square it so we can get a difference in brightness. 4 squared gives us 16. We already know where this is going. 16 becomes 2.5 to the third. Okay, which means we have a 3 times difference in magnitude. Okay, and since we're coming closer, we need to add together, which means it's going to get dimmer. So plus 4 plus 3 is going to give us an absolute magnitude of positive 7. Okay. And we'll do our last one. Is going to be going farther. In this case we have star E, which has plus 6. Okay, so still pretty dim, and it's 100 parsecs away. Okay, so 100 over 10, again we've gotten rid of the parsecs already, gives us 10. When we square that, we get 10,000. Okay. I'm sorry, 100. Gosh. 100. 10 squared is not 10. So 1,000. No, 100 squared gives us 10,000. It is 10,000. I was correct. 10 squared is going to give us 100. Yeah, 100. Alright, my math is correct. 100. Okay. And so that's our brightness change. Okay, again, see it down here. It means that we're going to go to 2.5 to the 5th, which means our difference in brightness is going to be 5. Okay, and since we're moving closer, we're getting brighter, so we're going to subtract. So we're doing plus 6 minus 5, which means our absolute magnitude is equal 1. Positive 1. Alright guys, and that's how we're going to find absolute magnitude. And I will see you guys in the next video where we're going to talk about distance. And we're going to go over a few equations where we're going to talk about how we figure out how far away an object is.